Okay, hello everyone. Good morning, or good afternoon, good evening, good night, whatever it is for you. And thanks for joining. And a big thank you to the organizers of this great event. Because nowadays we are all working from home, and it was a brilliant idea to construct this first working from home conference. And I know that they did a great job in a very short while. So today I want to share some experiences, and I want to talk about the test symbols which can appear in automation frameworks, automation environments, and some solutions that we apply against them. And you can see the contact information for me, and you can reach me out afterwards for any recommendations or questions. Because today in the session we have a limited time, and for some parts I will quickly go over them. Normally, I have some code practices and real samples, but for the code parts, I will go quickly. And if you are really interested on them, please reach me out for the implementation details. So this is the brief agenda for this talk. I will introduce the system under test in my study, and then I will talk about quickly the test automation environment. And then the most common test symbols that we face as a QA automation team, and the solutions that we applied to handle them. Let me introduce the system under test. In this study, the system under test was Mindsphere, which is a cloud-based open IoT platform. And you can connect your devices from the field, and you can collect data from your manufacturing lines, and you can upload them to the cloud by using the open APIs and UIs of the system. Or you can use this product as a development platform as well, and you can develop your own app and deploy it to the cloud by using these open APIs and UIs. It's a big system developed by globally distributed sites, so it was important for agile testing aspects. And inside, it has a complex structure. The architecture is built upon microservices concept. It is chosen because it has some advantages. It promises for some flexibility opportunities, but on the other hand, it has some challenges and difficulties as well. And they can cause to some testing challenges, because normally those microservices are working asynchronously and they are working independently. So we face some challenges in terms of a testing manner. And it is the test automation environment. On this picture, we can see how we implement, develop our test cases, and how we execute them in our pipelines. We have a CI runner, CI/CD pipeline, and we use GitLab CI runner for this purpose. And after we implement our test cases, we trigger our jobs, or sometimes we schedule some jobs to execute them. And we can execute all our test cases in a suite or in separated suites each night. And after each execution, we report our test cases with details and with attached evidences or screenshots or log files of the execution to our test management platforms. In our case, we use Jira and X-Ray, which is a plugin of Jira, as the test management tools and platforms. And as the main test development environment, we use Java language as the main development platform, and we develop our own framework. And of course, we use some additional libraries and frameworks. For example, for the main testing purposes, we use TestNG. And for API side, we use Java Jersey client, and for UI sides, we execute our test cases in a headed mode and in headless mode as well. So we use Selenium mainly, and some Gargoyle software libraries, and some additional libraries such as Mockito for unit testing, and Allure for reporting, and some others as well. And as I told, after each execution, we report our test cases automatically again from the code by calling the open APIs of X-Ray. So in this way, we do not lose any execution result or execution details. And let me continue with the testimals, what a testimal is, and their types and possible consequences. Normally, a testimal is defined as a weakly designed test case, which can cause to some potential problems. And they can cause really some critical consequences. For example, when we investigate the results of test cases, if a feature is working properly and the test case is passing, then it is the ordinary situation, then it is the no problem situation. And if the feature is not working properly, if there is a variation between the expected situation and the actual behavior, and if our test case is matching this situation, then it means that we are catching the bug or we are catching a defect. So it's a real bug. But we have some problematic cases as well. For example, if the feature is not working properly, but if our test case is not reporting a warning or alarm for that, it means that there is a bug on the feature, but our test case is not reporting it, so it is not catching it. So it's a silent horror cases, a silent horror case, and it can cause to some really critical consequences. For example, if we are not catching the bug in time, so it means that we will face the bug in later stages. Maybe the customers will report those bugs to us, and maybe it would be too late to apply our fixes against them that time. Or, of course, it will cause to some extra costs in the later stages. On the other hand, if the feature is working properly, but if we get some warnings and alarms and fail reports from our test cases, they mean false alarms for us. We are getting a failure report or failure warning, but it is not a real bug. So it's a false alarm. And of course, it causes some maintenance efforts and rerun efforts and analysis costs. But on the other hand, normally it seems less risky because it seems we are not catching a bug, but indeed they are as risky as the silent horror cases because it can again lead to some miss of some bugs. For example, we can illustrate this issue over a real scenario. On an airplane crash, the situation was like this. The pilots has had too many alarms on their screens. They were continuously getting some alarms and warnings on the screens. And when they investigate the bugs, they realized that they were all false alarms and they were not real bugs. So they just stopped looking at the screen because they were all false alarms. And after a while, when they get a real warning about the internal pressure of the cabin, they since they already stopped looking at that, they missed that real bug, and it caused a really fatal consequence. So they can cause really critical consequences. But what type of testimonials we can face? Normally, when we perform a survey, literature survey, we can find maybe more than 100 testimal types. There are a lot of them. But on this table, I wanted to summarize the most critical ones or the most common ones for us and for our product. For example, in our case, the structure of the product and the microservices concept leads to some of them, and the API testing, UI testing leads to some different ones. So on this table, we can see 5 major categories of them. The first one is stability related tests, testimals. The next one is distortive ones stemming from wrong assertions or mockings. And we can have some scope-related issues. Maybe we are not covering the features properly. Those are the scope-related issues. Or we can have some performance-related and structural testimonials which are related to the code quality in our test framework. So these are the testimonials which can appear in any automation framework. As I told in the beginning, they are not case-specific, case-dependent ones. If you are developing some test cases, if you are a tester or if you are a developer developing some unit tests, you can face any type of these testimonials, and they can result in some critical consequences. So they can be really, or they should be really taken seriously. And these are on this table, the test schemas are the most common ones. For example, the flaky tests are probably the most common one in the test development area, and some fragile tests which are broken when you change a parameter. You can mostly see any of them. So yeah, it looks scary because there are lots of them and they can cause some critical consequences, but it doesn't mean that we have nothing to do against them. We can apply some solutions against them, and on this table, I tried to list the solutions that we apply. But normally, firstly, let me introduce the story which lies in the background of application of these solutions. Our QA team is responsible for the implementation of test cases. But at some point, we realized that we were blocked from some other tasks to implement those test cases. And at that point, people were very unhappy, and we started to investigate the reasons and root causes for those problems. And we listed our problems. We found the test schemas leading to those problems, and found the root causes for those test schemas. And one by one, we started to develop our solutions. And on this table, we can see the summary of those problems. We have three major categories of test problems. First of all, the maintenance efforts. The second one is the escape bugs, which are coming from the customer. And it is not a desired situation because escape bugs means we are not catching the bug, and the customers are reporting some bugs to us. As we discussed in the beginning, it is not a desired situation. And the third and the last category is the refactoring efforts stemming from the weaknesses in the test code in our framework. So I will start with the first one, the maintenance efforts. And the tests causing to maintenance efforts were mostly the flaky tests. And when we investigate the reasons of flaky tests, we found out that the asynchronous waits are the most probable reason for the asynchronous flaky tests. And an asynchronous wait is meaning a request which does not wait for the response properly. So in our case, when you send a request to the microservices structure, to the cloud, to any of the service, you will respond by one of them. But it doesn't mean that the whole transaction is completed, because normally when we get a 200 response, a successful response, it means that it is not a forbidden one. We are not getting 403. And it is not in a bad format because we are not getting 400 response. It is 200, but still we don't know if our request is performed fully. The whole transaction is completed. So what we should do is to ensure the function or the request is performed. So we can say this scenario over a sample simulation scenario. In this one, what I do is I'm sending a create object request, and then I will assert if the object is really created. So it is, as I said, just a simulation, and what a create object method does is just sleeps for 5 seconds and then creates the object. So what I do is after I send my request, if I send the assertion request immediately, I would face a bug because on that time the object was not creating. And it is created after 5 seconds. So what I do is I'm polling for the result with a polling interval, with a polling frequency, and it is 1 second for me in this case, and I will wait until 7 seconds. It is the maximum acceptable time for me, and after 7 seconds, if the object is not still created, then I will set the result as a fail. So what I do is basically frequently poll for the expected result instead of immediately sending my request. So in this graph, we can see how it helps. On the same number of executions, instead of 7 or 6 failures, we get only 1 in this case. And in most situations, we do not get any failing results after applying the solution stemming from the weaknesses in the test code. Another solution that we apply against flag test was the cleanup mechanisms adapted in the code. These are the methods to clean the objects created until that point. We used the methods coming from TestNG framework, such as after method, or you can use after suite as well. And in this case, even in the unexpected failing cases, all the objects created until that point are deleted. And in this way, we eliminated the risk of conflicts between consecutive executions and the unnecessary load in the systems as well. And grouping of the tests are very important because sometimes we can face some suite dependency cases. If a test is not executable with some others in the same suite, then it means that we have some dependency cases. And with the usage of annotations and tags and labels, we are able to solve this problem. We are grouping the similar test cases together, and we can execute them all in a suite. And we are keeping test history to be able to make a comprehensive analysis. Normally, if we have only one result in our hands, then we are not able to make a comprehensive analysis. But whenever we keep a test history, the previous result as well, then we can go to the previous executions and previous details of executions, and we can check what went there. What was the change if we face a problem? If it was a pass in the previous one and if failed in the current execution, then we can check the change in this way. I will just skip this because we don't have much time. And for our second major category, the escape bugs, we have actually started to investigate why we had this situation, because normally we were executing our test cases and we were covering the features and the functionalities of the system. Then if we were executing our test cases, why we had too many bugs coming from customers? And at that point, we realized that some customers were using some different environments than we did for testing purposes. And we understood that executing the test cases on a limited execution environment was not sufficient. And we had to execute our test cases in different environments. For example, we have some hardware issues. So for that purpose, we developed a machine manager server, which provides us a different combinations of operating systems and hardware versions. And in this way, we executed the test cases in different environments. And for the UI cases, we developed a Selenium grid. And in this way, we tested our cases on all supported browsers instead of just a single one. We executed the test cases on all supported browsers. And similarly for the test inputs, instead of executing the test case with a limited test data type and test data value, what we did is we created the test pool, which includes all possible and supported data types with different data values, with different ranges. For example, we included the corner cases, we included the boundary values as well. For example, if I test a feature upload functionality with only an integer value, then I still do not know if it will work again with a string value. So in this way, I executed the features with a different range of test inputs. So in this way, we eliminated the bugs stemming from the variations between customer environments and testing environments. And finally, about the code quality related issues, the biggest factor affecting this code quality was the code duplication in the framework. So I will illustrate this over a scenario. On this picture, we see two Mona Lisa images. So if the owner of this gallery wants a change from me, from the drawer, what he will do is to change, to apply the change on both of them. Because, for example, if he wants a bigger smile on Mona Lisa face, and I have two images on the wall, so I will apply the change on both of them. But what if I had only one of them? Or maybe I have one and I have multiple reflections of those. So in that case, I would apply the fix on only one. So my effort would not be doubled. So if we have too many same codes on different regions of the framework, then if we need a change and if we are working in an agile environment, so it's a very possible situation. So we would not, if we don't want to apply duplicated efforts, then it's the appropriate solution to have only one reference code and use it from different points of usages. And I will quickly tell what this does. We move all the duplicated codes in a single point, and we call it from different points, and this can show how it looks like. After we apply it, at least it is more readable and understandable and manageable now. And as I told, it reduces the maintenance efforts. And of course, we perform some peer reviews to find the weaknesses and vulnerabilities in the codes. And thanks to these peer reviews, not a code which is not reviewed is merged in the master branch, and each code is reviewed by another colleague in the team. And we can integrate some tools in our pipelines. For example, we use in our case SonarQube to find some weaknesses and vulnerabilities in the code. And in this way, it can make some alarms for the users and developers, and we can make and perform some investigations on the code. And I have some advices for the additional automation steps. For example, instead of making manual queries on Jira, we can do this over code. If you are closely interested in the implementation, you can reach me out. I will skip quickly. And the next one is a usage of S3 buckets, because storing the test inputs and test outputs in local environments is not difficult, and it is not easy to manage them in our local environments. So we can upload our test inputs or test outputs to S3 buckets. For example, in the failing cases of UI tests, we can make a screenshot in the failing point, and we do not want to lose that evidence of failure or the screenshots for the further investigation. And my final advice is to use graphs and some monitoring tools, because, for example, in our case, some metrics were really critical. For example, the asset counts in our environments were critical. So when I construct these graphs and dashboards, I can visualize what's going on in our environment. So I reduce the risk to overlook any limit violations. And I can upload my metrics to the tools, and I can monitor them on the graphs. This shows how I do that. I use the Amazon CloudWatch services, and I upload my metrics, and I transform them to the monitoring tools. And I'm about to finish, and this was the table which I showed in the beginning. Again, I want to remind it to you. It is just a summary. These were the problems that we faced in our environments, and what we wanted to do is to list the root causes and apply the solutions. And we can regard this as again as a summary of this talk. My last sentence is I wanted to just make an awareness on the test smells, possible test smells in automation environments, and their possible critical consequences. So please be aware of test smells in your automation environments and develop solutions against them. Thank you for listening to me. From this platform, I think I cannot see the questions. If there are, Matt, maybe you can help me if there are any. Or otherwise, as I told, you can reach your questions to me afterwards. Thanks again for listening to me, and thanks for this great organization. I hope everything will go fine again, and see you soon. Bye.